This video is about solving quadratic equations by factoring. So we did factoring for quite a while, and now we're actually going to use it to solve stuff, which was kind of the whole reason we were going over it. So let's check out how that works. The crux of it is this magical thing called the zero property, and it says that if a times b equals 0, then either a or b equals 0. We're going to use that in conjunction with factoring to solve quadratic equations. Let me go ahead and get that fired up here. So let's look at our box here. So step one is your original equation. I'm going to go ahead and copy that. And according to this, it is 3x squared minus 17x plus 10. Cool, cool, cool. We're going to go ahead and factor that. Okay? So I believe this one's kind of already done for us. I'm going to just go ahead and factor it. That'll be 3x minus 2 and x minus 5 equals 0. I'm not going to waste your time factoring that. I don't have the space right here, but I'll do some more examples here in a minute. So we're going to take our factored quadratic here, and now we're going to apply the zero product property. This is where things get a little bit interesting. So I'm going to say 3x minus 2 equals 0, and also x minus 5 equals 0. And I don't know why I put the parentheses on that. You don't need them. And we're just going to solve that. So if I did that kind of off to the side here, 3x minus 2 equals 0, I will add 2 to both sides, get 3x equals 2, divide everything by 3, and we get that x equals 2/3. So x equals 2/3. On the other side, right, x minus 5 equals 0. I would just add the 5 over, and I would get that x equals 5. So those are the two solutions to my quadratic, in this case, equation. So the gist of what we're doing is we're taking our quadratic, we are factoring it, and setting each factor equal to 0 to use a zero property to solve that quadratic for us. So let's see how this works. Let's take a look at b. B is a bit of a beast, I'm not going to lie to you. This one we would factor by grouping, just like we've been doing before. 12 times negative 10 is negative 120. Oof. So I'm going to go ahead and write that, I guess, over here in the margin, that my goal is negative 120. Looking at this, I'm factoring negative 120. My sum has to be negative 7. That means to me in my head what I'm thinking is those factors have to be relatively close to each other. I mean, for example, if we took, negative 120 and 1, you're not going to get anywhere near negative 7. So my guess is probably going to be 15-ish something. So let's go ahead and throw some factors out there. How about, my goodness, negative 15 and 8. The reason I default to 15s, by the way, in case you were wondering when it comes to multiples of 60, is because when I learned to multiply, it was using an analog clock. So that's, thank you, Miss Stelzer, for for that lesson years ago. Anyway, let's see, negative 15 plus 8, that sum is, holy cow, it's negative 7. Well, I'm getting good at this. All right, so those are most likely our factors. I'm going to double check so I don't waste a bunch of time. Do negative 15 and 12 have a common factor? Yes, they do. Do 10 and 8 have a common factor? Yes, they do. So I'm relatively confident this will factor by grouping in that order quite nicely. Let's see what we get. Let's see here, 12x squared. And we get, let's see, minus 15x plus 8x. And that last term was a negative 10. And we can factor that bad boy. We can take a 3 from negative 12, or from 12 and negative 15. And we'll get 3 times the quantity, 3x. 3x times the quantity 4x minus 5. And then we can take a 2 out of the other part. And we will get 4x minus 5. And then we'll group those two together. And we'll get 3x plus 2 and 4x minus 5. And I didn't pull the 0 down. I was just being lazy. I'm going to put the 0 back on there now. And now we can go ahead and apply the zero product property. So what I'm going to do is say 3x plus 2 equals 0 and 4x minus 5 equals 0. And we'll solve these two independently and we'll have our pieces to put back together. So on the left one, we'll subtract 2. You will get 3x equals negative 2. We'll divide by 3 and get that x equals negative 2/3. On the one on the right, we're going to add 5 to both sides. We'll get 4x equals 5. We will divide by that coefficient of 4 and get that x equals 5/4. Oh, the internet catch up with me there. All right, and those are our two solutions. So what we did, we took our equation, we factored it. We took each factor and set it equal to 0, and we got our two solutions. And quadratics normally have two solutions. So let's take a look. For the sake of space, I think we're going to do maybe B, D, E, and G, just so this isn't too much of a mess. So let's look at D next, and I'll kind of do it off to the side here. So let me label what I'm doing before I confuse myself. So that was problem B. We'll do problem D kind of in the margin. Let me scroll down so my head's not in the way. If I can find my mouse, my goodness. There we go. All right, now my face isn't in the way. Let's take a look at this. So to me, what strikes me is our first term is a perfect square, and our last term is a perfect square. This might be a perfect square trinomial. So let's factor it that way and see if it works out for us. So the square root of 4 is going to be 2. Square root of x squared will be x. And the square root of 9 will be 3. The middle term is positive, so I'm assuming it will work like this. Let's double check. Let's see. So 2 times 2 is 4. Cool. 3 times 3 is 9. Cool. 2 times 3 is 6. Times 2 is 12. Hey, that worked out really nicely. So we've only really got one thing. It's set twice. We shouldn't have to do it twice because we do it once we know the answer. So let's set this equal to 0. 2x plus 3 equals 0. We'll subtract the 3. We'll get 2x equals negative 3. Ugly 3 I drew. Divide by our coefficient 2, and we get x equals negative 3 over 2. And in this case, I should have boxed the other one. My goodness. In this case, it's only that one solution because they're both kind of the same thing. So that's pretty easy. How does the next one look? Number 18. What can we do with this? So the first thing I'm noticing just off the top of my head on number 18 is that I can factor out a GCF here of 18 and negative 98. I can divide both those by 2. So I'm going to go ahead and do that real fast. See if I can squish this in down here. So if I factor out a 2 first, I get 9x squared. 98 divided by 2 would be 49. Aha! This to me looks like a difference of 2 squares inside of here, right? I've got a perfect square, a minus, and a perfect square. So let's further factor that into a difference of squares. And we'll get 2 times 3x plus 7, 3x minus 7 equals 0. Okay, so now we're going to use the 0 property. So technically here, we would do the 0 property 3 times, but one of them is what I would call pretty stinking extraneous. We're going to set 3x plus 7 is equal to 0, 3x minus 7 equal to 0. We also have another factor, which is 2. 2 equals 0 doesn't make any sense, so we're basically going to throw that out as extraneous. Make sense? Why do work if it doesn't make sense? So let's split this up, and I think I can fit this all on the screen. 3x plus 7 equals 0, and 3x minus 7 equals 0. We will start by subtracting 7. We will get 3x equals negative 7. Divide by 3. And we'll get that x equals negative 7/3. I bet the other one is the opposite of that. Okay, I'm going to add 7. We will get 3x equals 7. We will divide by our coefficient 3 and get that x equals 7/3. Not too bad. I imagine that would not be quite as quick if we had to use the quadratic formula. Okay, let's take a look at G. Now, G is a little bit tricky. It's not really significantly different, but it's written in a way that's designed to confuse you if you're not comfortable with these. And what I mean is it doesn't say it's equal to 0. So we're going to make it equal to 0 based on the information that we have. So to do that, all I'm going to do is take this equation right here. I'm going to subtract 3 from both sides. So let's go ahead and rewrite that. If I subtracted the 3 from both sides of the equation like this, it's 5x squared plus 2x minus 3 equals 0. I think that makes a little more sense for you guys since this is the way that we've been solving them. So now that it's been rewritten, let's take a look. This looks to me like I can't do any of our special cases. So I'm going to multiply 5 times negative 3. I'm going to get negative 15. I'm going to put that off to the side. So I'm looking for factors of negative 15 that equal 2. They've got to be pretty close to each other to get 2. So maybe, I don't know, negative 3 and 5. Let's see, negative 3 plus 5, that would be negative, well, that would give us 2. 3 for 5, okay. Actually, will that work? So let's check it. Do negative 3 and 5 have a common factor? They do not. So that's not the right order. Let's flip it and see if it works. Maybe we'll do 5 and negative 3. Let's see if that works. We still get the 2. 5 and 5 have a common factor, and negative 3 and negative 3 have a common factor. That seems like it's going to work a lot better. So let's go ahead and rewrite 5x squared plus 5x minus 3x minus 3 equals 0. And if we factor by grouping, looks like I can pull a 5 out of my first pair here. So we get a 5x, and we get an x, let's see, plus 1. And on the back, we can factor out a negative 3 and get another x plus 1. Yay! So we'll go ahead and put our two groups together. 5x minus 3 and x plus 1. This time I'm actually being diligent writing the 0 every time. So we're going to set each of those to be equal to 0, and I'll do that kind of over here under my little face avatar type thing. Here we go. 5x minus 3 equals 0. So we can add 3 to both sides. Get 5x equals 3. Divide by our coefficient 5. And we get that x equals 3/5. So there's one of our answers. Our other one was x plus 1. X plus 1 equals 0. That's really easy. We just subtract the 1. And we get that x equals negative 1. So this would be our solution set. So this is primarily the way that we're going to be solving quadratics by factoring. So we can take this idea and we can apply it to what we did in 7.1. We could have solved it this way instead of the other way. This is what this question is about. So we're asked to determine the dimensions of a rectangle with an area of 525 square feet. that can be enclosed by 100 square feet of fencing. And this was the quadratic that we wrote to model the situation. So we're going to solve this by factoring. And I'm actually going to do this really fast because I don't want this video to drag on forever. So if we factored that, we're going to end up with L minus 35 times L minus 15 equals 0. So if we applied the 0 property, our answers would be the opposite of 35 and the opposite of 15. So 35 and 15. So L equals 35 or L equals 15. So what do these solutions of the equation represent? Possible lengths of the rectangle, I guess. Possible lengths of the rectangle. What are the dimensions of a rectangle with an area of 525 that has a perimeter that is enclosed by 100 square feet of fencing? Looks to me like it's either 35 by 15 or 15 by 35. Pretty easy. So explain why that works. Well, 15 plus 35 is going to be 50, and 50 times 2 is 100, so the perimeter works. And 35 times 15 gives us 525. So there you go. Okay, let's see what number 2's got for us. A park has 2 rectangular tennis courts side by side. Combine the courts have a perimeter of 160 yards and an area of 1,600 yards. We're going to write the quadratic equation that can be used to find L. So we're going to take the exact same kind of pattern that we did last time. And that will be, let's see, negative L squared plus, oops, I'm writing on the wrong line, my goodness. Negative L squared plus 80L equals 1,600. Now, the reason I wrote this, that was the path that we took in the previous problem where we did this. So I just followed the same pattern and put our new numbers in here. The 80 came from half of 160, was half the perimeter. Okay, let's see here. Explain why we need to write the equation before we can solve it by factoring. Well, we can't factor it in the form it's in, right? So we got to shift this over, and we also have to make sure that our leading coefficient is positive. We can't have a negative L squared. That's kind of no bueno. So what we're going to do is we're going to put it that way so that we can factor it by the 0 property. Let's see. And that gives us, let's see, first negative L squared plus 80L minus 1,600 equals 0. We're going to flip the signs. I'm going to multiply times a negative 1 to make it a positive in the front. And so that gives us L squared minus 80L plus 1,600 equals 0. We're going to solve this quadratic using factoring. Okay. Well, it seems to me that this is going to be kind of a mess, right? Factors of 1,600. Whew. Or is it possible that this is a perfect square trinomial? That would make our life a lot easier. So we're going to try that and see if it works. So the square root of L squared will be L. The square root of 1,600 would be 40. I'm going to put a minus 40 like this because our middle term is negative. Let's see if it works. Okay, L times L, L squared. Negative 40 times negative 40, positive 1,600. 1 times negative 40 is negative 40. Negative 40 times 2 is negative 80. Sweet. We could have done that by grouping, but looking at factors of 1,600, that didn't seem like it was going to be very fun. So if we use this, if we apply the 0 property to this, that'll be L minus 40 equals 0. So L minus 40 equals 0. And then if we add that 40 over, if I can make it really tiny, then we get L equals 40. D, we only have one distinct solution because it is a perfect square trinomial. So both factors would kind of be the same thing, right? Which we learned the other day. So I'm going to flip over to this part. I think this is a very important skill to have, and that is essentially doing this backwards, okay? So let's take a look at B. It says, write the quadratic equation in standard form that has the solutions -1 and -7. So I'm going to start by writing the two linear equations that make this work. And that would be x plus 1 equals 0 and x plus 7 equals 0. So I took my mouse, this solution, I did the opposite of it, right? And I got this. So we're going to write this as factors, okay? That would be x plus 1 and x plus 7. Now we're going to multiply the factors, which gives us, let's see here. Oh, I'm sorry, those are the two, and then it wants us to write it the way I just had it, x plus 7. Okay, and then it wants us to multiply our binomials. So let's see, x times x is x squared. X times 7 is 7x. 1 times x is 1x, so 7 plus 1 is going to be plus 8x. And then 1 times 7 will be 7. And there's the equation. So you can take the answers and work backwards. So let's see here. Write the quadratic equation in standard form whose solutions are 2/5 and -1/2. Okay, so these are a little bit trickier. So this is the way that I look at it. I start off by saying that well, let's do it this way. X equals 2/5. I want to clear the fraction first. So I'm going to multiply both sides of this by 5. So if I do that, let's see, times 5, then we get 5x equals 2. Now I want this to equal 0, so I'm going to subtract the 2. So -2, -2, and we get 5x minus 2 equals 0. So there's one of our terms. We'll do the same thing for our other answer, which was, I believe, -1/2. So we'll say x equals -1/2. So what I want to do, I want to start by clearing the denominator. So I'm going to multiply by it. 2 times x will be 2x equals -1. Okay. I want this to be equal to 0. Remember, 0 property. So I'm going to add 1 to both sides. Add 1 to both sides. Now we'll get 2x plus 1 equals 0. And we can put those two together. Those are two factors. 5x minus 2 times 2x plus 1. And we end up with, let's see here, 10x squared plus x minus 2. So you can definitely work backwards. Now, once you've done enough of these, if you can see this pattern, you can actually solve this part over here in your head very quickly, which is kind of what I've come to end up doing. So why don't you give it a shot and see how it goes for you? I'm going to go ahead and do, let's see how much room I have. Let's do C together, because you've already seen an example like D. So I'm going to take off to the side, x equals 2/3. That is an ugly 3, Mr. Clark. Jiminy Cricket. Okay, step number 1, clear that fraction. So times 3. We get 3x equals 2. We'll subtract the 2 away, and we will get 3x minus 2 as our first term. Our other term was, just x equals 2. So we'll just subtract that to make it equal 0. So x minus 2 equals 0. This should have been equal 0 over here too. So there's our two factors. 3x minus 2 and x minus 2. Let's see, 3x squared, that's 6, 7, 8, so minus 8x, and negative 2 times negative 2 will be positive 4. So there's our quadratic equation in standard form. And ooh, we might have enough room to do both of them. All right, cool. So let's try the last one. X equals negative 3 over 2. I'm going to clear my fraction. We'll get 2x equals negative 3. I want it to be equal to 0, so I'm going to add 3 to both sides. Get 2x plus 3 equals 0, so there's our first one. Our other one is x equals 5 over 2. We will multiply by 2 and get 2x equals 5. We will subtract the 5 and get 2x minus 5 equals 0. So here's our two, goodness, catch up computer. So here's our two factors. Well, or two factors. I'm going to write those down. I'm sorry, I'm trying to do this on two screens at once. And let's see here. We get 2x plus 3 and 2x minus 5. So we get, let's see, 2 times 2, that's 4x. We get 10 and 6. So we get negative 4x. And then 3 times negative 5 is negative 15. And there we go. And of course, C and D and B technically, I've been kind of bad about it. Those would all equal 0. I'll go back and correct that. Be a good math teacher because they were solved. So that's all there is to these. It's really important that you can solve them forwards and backwards. It will save you a lot of time and a lot of headache later.